As with most airplanes, pitch is controlled on the 777 with elevators and a horizontal stabilizer. The left elevator actuators are powered by the left and center hydraulic systems and controlled by the left 1 and center aces. The right elevator actuators are powered by the left and right hydraulic systems and controlled by the left 2 and right aces. Pilot inputs to the elevators are through the familiar control columns. Elevator field forces in PFC normal mode are variable, based on airspeed. In general, control column forces increase as airspeed increases. If the system reverts to secondary or direct mode, elevator feel changes to 2 fixed levels of force. Control column force is lower with flaps extended. The force switches to a higher level with flaps up, which prevents over-control. Now let's look at stall warning. The stall warning system consists of a stick shaker. There is no oral stall warning. The stick shaker activates at the minimum speed displayed on the PFD airspeed indication. This airplane has a stall protection feature which reduces the possibility of reaching stick shaker. The lowest speed to which the airplane can be trimmed is minimum maneuvering speed, the top of the amber band. Maintaining a speed slower than the minimum maneuvering speed requires continuous control column back pressure by the pilot. If airspeed continues to decrease into the amber band, the ICAS caution message, airspeed low, displays. Also, if the autothrottles are armed, they will automatically engage prior to stick shaker speed to prevent speed from reaching stick shaker. Overspeed protection limits the speed to which the airplane can be trimmed to VMO/MMO. Speeds above VMO/MMO require constant forward control column force by the pilot. An ICAS warning message, overspeed, and associated oral alert the flight crew of an overspeed anytime an overspeed condition exists. Releasing the forward force on the control column allows the airplane to return to a speed at or below VMO/MMO. The forward control column force needed to keep the airplane in overspeed reduces as bank angle increases. Now let's look at stabilizer control. The stabilizer is powered by the center and right hydraulic systems and controlled by all 4 aces. On the ground, the stabilizer is positioned directly with the pitch trim switches on the control wheel, or the alternate pitch trim levers on the control stand. There are 2 stabilizer position indicators, one on each side of the control stand. The scale is in units of stabilizer position. The white diamond shows the current stabilizer position. The illuminated green band is computed by the FMC. The allowable range in which the stabilizer can be placed for takeoff is based on airplane weight, CG, and takeoff thrust. The green band is not displayed in flight. The FMC calculated takeoff trim is displayed on the takeoff reference page. If the stabilizer signal is not available or is invalid, the green band and pointer are not displayed. During pre-flight, a nose gear oleo pressure switch provides an automatic cross-check of the CG to ensure the correct green band is selected. If the nose gear pressure switch disagrees with the FMC computed stabilizer green band, the advisory message "Stab Green Band" displays. When this happens, recheck the gross weight and CG. An incorrect entry may be the cause. Here is an opportunity to explore the use of the trim switches. Touch the green arrow to continue. Now, let's look at trimming the airplane in flight. Pitch trim signals from the pitch trim switches and the autopilot do not position the stabilizer directly. Here is an example of automatic trimming with the autopilot. First, pitch trim signals change the trim reference speed in the PFCs. The PFCs then send signals through the ACEs to position the elevators. Next, the stabilizer moves to a new trim position required by the new trim reference speed. Then the elevators streamline with the stabilizer. Manual trimming with the pitch trim switches is the same. However, when the autopilot is not engaged, manual trim is only necessary when changing airspeed. Manual trim is not necessary when changing configuration. Trimming with the pitch trim switches is inhibited when the autopilot is engaged. The pilot can also override the pitch trim switches by moving the control wheel in the opposing direction. Another way to set trim is to use the alternate pitch trim levers on the control stand. The levers are spring-loaded to neutral and must be moved together. The alternate pitch trim levers move a set of cables that control the stabilizer directly in all modes. Moving both levers in the same direction sets valves in the stabilizer trim control modules. This sends hydraulic fluid to move the stabilizer. The stabilizer moves at a reduced rate if one STCM is inoperative. Pitch trim commands from the alternate pitch trim levers will override autopilot pitch trim commands, but will not disengage the autopilots. The lever should not be used with the autopilots engaged. The alternate pitch trim levers also have priority over the pitch trim switches. There are two guarded stabilizer cutout switches on the control stand. These switches control hydraulic power use for stabilizer positioning. The center stabilizer cutout switch controls the center hydraulic supply to the stabilizer. And the right stabilizer cutout switch controls the right hydraulic supply. Each toggle switch has two positions, normal and cutout. The switches are guarded to normal. When a switch is in the normal position, the hydraulic supply shutoff valve is open. In the normal position, hydraulic power to the stabilizer is automatically shut off if unscheduled stabilizer motion is detected. When a switch is in cutout, the hydraulic shutoff valve is manually closed. If you have one switch in cutout and the other in normal, only one stabilizer trim control module operates. Now let's look at yaw control. Yaw control is provided by the rudder pedals, the rudder trim system, the rudder ratio system, and the yaw dampers. Hydraulic pressure is required to operate and trim the rudder. There are three power control units, PCUs, which operate the rudder. Each PCU is powered by one of the three hydraulic systems and controlled by right, center, and left 1 ACEs. The rudder pedals can be adjusted for pilot's leg length by moving the rudder pedal adjust crank from its stowed position and rotating it in the desired direction. A pin in the knob locks into slots when the knob is stowed. The crosshair on top of the rudder pedal adjustment crank housing is used as an aid in positioning the seat for optimum outside visibility and inside scan. The rudder trim control and indicator are located on the aft dial stand. The rudder trim indicator shows units of rudder trim. The rudder trim control has nose left and nose right positions, and two rates, high speed and low speed. Normal takeoff setting is rudder trim at 0. Observe the rudder trim being set to rudder trim left 2 units. The control is spring-loaded to center position when released. The crew can cancel manual trim inputs with the manual trim cancel switch. When put, it causes rudder trim to return to 0 at a high trim rate. Cancel the rudder trim with the manual trim cancel switch. There are no separate yaw dampers on the 777. In flight, the PFCs send command signals to the ACES and to the PCUs for Dutch roll damping and turn coordination. In secondary mode, yaw damping is available if inertial data is available. Yaw damping is not available in direct mode. Now, let's examine the rudder ratio system. The 777 has no separate rudder ratio unit. The PFCs calculate the amount of rudder deflection required based on airspeed. At low air speeds, the rudder has full deflection. As airspeed increases, the PFCs gradually reduce rudder deflection. This assures structural protection for the rudder. In secondary and direct modes, rudder response defaults to 2 fixed ratios. Flap position determines rudder response. With flaps up, rudder response is less than with flaps down. Let's look at 777 features that aid the flight crew and improve passenger comfort. Gust suppression increases passenger comfort when a side gust hits the vertical tail. The gust suppression transducers send signals to the ACES. The ACES send this data to the PFCs to adjust PCU commands to dampen the force of the side gust. Thrust symmetry compensation, or TAC, assists the pilot in maintaining directional control after an engine failure. TAC immediately counters asymmetric thrust with a high-rate rudder command. TAC also assists the pilot when thrust levers are split. This is indicated to the crew through a shift in the rudder pedals and an automatic change in the rudder trim. TAC is armed above 70 knots and is operational during manual and autopilot flight. TAC is not operational during reverse thrust operations. A thrust asymmetry switch on the overhead panel allows the crew to switch off the TAC. Disconnect the TAC. If TAC is automatically or manually disconnected, The ICAS advisory message Thrust Asymmetry Compensation displays. A wheel-to-rudder cross-tie is available below 210 knots. Control wheel inputs deflect the rudder up to 8 degrees. This allows the pilot to control the initial effects of an engine failure by using control wheel inputs only. The wheel-to-rudder cross-tie is available in normal mode only. Turn compensation eliminates the need for the pilot to add column back pressure to maintain level flight and turns up to 30 degrees of bank. Partial compensation is provided between 30 and 60 degrees of bank. Turn compensation is only available in normal mode. Now let's look at pitch and yaw non-normals. If one control column or one control wheel jams, applying force to the other column or wheel overrides the jam. The advisory message Stabilizer Center or Stabilizer Right displays if the respective stabilizer trim control module is inoperative. The message appears for an auto shutdown signal or if the respective switch is in cutout. With one stabilizer trim control module operational, pitch trim is still available at a reduced rate through the pitch trim switches and alternate pitch trim levers. When both stabilizer cutout switches are in cutout position, the advisory message Stabilizer Cutout appears. In normal mode, with both switches in cutout, pitch trim is still available. Pitch trim inputs through the PFCs position the elevator to trim the airplane. When the stabilizer position is not set within the green band, and takeoff thrust is selected on either engine, the warning message Config Stabilizer and associated oral and lights display. Retard the thrust levers to idle. The master warning oral and lights are canceled when the thrust levers are retarded to idle. 10 seconds later, the ICAS message disappears. Before attempting another takeoff, set the stabilizer trim. The warning message Stabilizer displays if uncommanded stabilizer motion is detected or if the stabilizer is inoperative. Move both stabilizer cutout switches to cutout. The stabilizer warning message is replaced by the stabilizer cutout advisory message. To preserve elevator authority, do not exceed the airspeed at which the stabilizer message occurred. With the airplane in this condition, the landing will be made with less than normal landing flaps. When rudder trim is set to greater than 2 units and takeoff thrust is selected on either engine, the ICAS warning message Config Rudder displays. Retard the thrust to idle. The master warning oral and lights are canceled when the thrust levers are retarded to idle. 10 seconds later, the ICAS message disappears. Before attempting another takeoff, reset the rudder trim to 0.